So we want to get the average rate of change of gorilla weight, of cost with respect to gorilla weight. Did I say that right?
Something along those.
Yeah, I did. I want to make sure I've written it correctly. It's kind of unusual if I do. Okay, so on the interval, weight interval from 400 to 450 pounds, well, the weight interval, if this is 700, then this would be 350. So I'm going to say 400 to 450 pounds. Okay?
Yeah.
So that is the interval. $400, $450, and on that interval, the cost goes from whatever the cost is here to whatever the cost is here, right? Okay? So we have a fundamental triangle up here. The run is 50 and the rise is whatever this distance is, right? Okay? So, now we actually have two options here. We could extend this to a bigger triangle that has the same slope, because we could then estimate more effectively, right? Okay?
Mine's not that tiny on my.
So we could do that. Okay, but I'm gonna just do it with what we have here. So the rise, you know, over here and over here. This is a corresponding interval of the y-axis. Now, there's the interval. There are 1, 2, 3, 4, 5, 6, 7.5 of these intervals in the 15,000, so that interval appears to be 2,000. Okay? Understand what I just did? Rather than trying to estimate this value and this value, I just estimate how long that interval is. It appears to have length 2,000. Well, what's the rise then? What's the rise and what's the run?
Well,
The rise?
I can't see it.
On my graph, I'm doing it on my graph.
Okay, what
Yeah,
I
I
just
did
said
it on
was
my
we
graph, so
projected
that's real different.
over to here, and based on the fact that this is 15,000, this looks like about 7.5 of them going to 15,000, just the way my fingers came out, which just coincidentally ended up with a convenient number like 2,000. Okay? Now, one way or another, you estimate the length of this, right?
Yes.
Then, if this length is 2,000, what's the rise?
The length is 2,000?
Length of this interval here is 2,000, so this distance represents
So then the
2,000.
rise would be 2,000?
Yeah.
What's the run?
50.
The run would be the distance on the x-axis.
Yeah, down here it's from
Yeah.
400 to 450,
So
that's
that's
50.
a run of 50, but the rise is not 2,000, because if you go from here to here, you go down 2,000.
So it's negative. Okay.
The rise is negative 2,000. It's clear that that slope is negative, right?
Yeah.
Means it's getting cheaper to feed the gorilla as he gains weight. Okay?
That's not true for me.
So this triangle here, if we bring this triangle over here,
As you eat a little Debbie cake.
the run is 50, the rise is negative 2,000,
No, McDonald's.
and the slope is
Exactly what I'm saying though, it's like.
negative 40, meaning it saves us $40 a year.
They have a fat grill.
Right. Saves us $40 a year every time that gorilla gains a pound. Doesn't make a lot of sense, but that's what the graph is telling us. Okay?
I mean, you can make it make sense.
So, what's the weight of the gorilla that costs the most to feed?
It's about, yeah,
Around
12.
212.
12, yeah.
Yeah, that one's pretty easy, right? Okay,
Somewhere in that general vicinity.
so according to my graph,
208 maybe.
I mean, that's my graph too, but this one's mine. It looks like the weight's about 350, okay? And I don't have a good place to label that. So I'll have to cross lines here, but right there is the weight of the most expensive gorilla, which corresponds to the W coordinate of the peak of this graph, right? And how much does it cost? Well, you can answer that a little over 15K. Okay? What do you think? What about the maximum rate of change of the cost with respect to gorilla weight?
Would that be like the most it takes to feed it and the least it takes to feed it?
Now, I would give you the maximum rate of change because the rate of change can be over an interval as small as you like, right?
It's gonna be the biggest slope.
So, yeah, the rate of change is the slope, right?
Yeah.
Where's the slope greatest?
Somewhere on this side.
Between 500 and, I'm gonna pretend that that's
Yeah.
300.
So I'm saying, well, I'm just going to identify it. Use that color. What color could I possibly
where it
use
goes
here?
up.
I'm just going to use
That where it
white.
goes down.
So like between 0 and 212?
'Cause that's the-
Okay, right there's the maximum slope, right?
Okay.
I didn't even think about going up and stuff like
So like where is it the most?
Where it's the steepest.
And that's your maximum rate of change. So you just take any triangle that has that slope, you can extend it as far as you like, and you can estimate the rise and the run. Okay? Looks like the rise is, 6K, and the run is maybe 90. Okay? So rise 6K, a run of 80. And they divide that by that, and you get 775. Okay? Okay? So at that point, every pound the gorilla gains is going to cost you $75 a year. Well, I didn't say it was cheap to maintain a gorilla, did I?
No.
So, there are also other issues. You got to keep them happy. You got to watch out for safety. They're usually not too aggressive, but if they get aggressive, boy, they're strong. So, you can get hurt bad or killed easy. Okay, well, anyhow, that's that.